would ever become available to a wider public.
The latest technology that came in at the end of the 16th century was the idea of the chained library, whereby books could be instantly accessible to anybody who visited the library, and by simply extracting a book with the chain just long enough for the book to be lowered from the case onto the desk in front of the reader. And there the person could study the book as much as they wanted, with no fear of them being able to remove it.
For books to become generally available, they would have to lose their chains and become smaller and more affordable. Today, books are everywhere, written in hundreds of languages, about thousands of subjects. Once the exclusive property of a small, educated class, they have become the foundation of modern culture. In the past few years, a competitor to the book has begun rooting itself in the culture of the young. But when the ancestors of the modern computer first appeared, they too were fabulously expensive, and they too were in the hands of a mathematical priesthood. 45 years ago, the idea that computers would ever play a popular role seemed even less likely than that illuminated manuscripts could lead to the paperback book.
Even mathematicians found computers very difficult to use. They had to prepare their programs in the arcane language of the computer, punch them onto tape or cards, and bring them to a computer center to be run, and it rarely worked first time.
Say, what's going on here? Something must be wrong with the oscilloscope.
I found programming on the old big machines to be unbelievably frustrating, and I used to get really angry about it because I couldn't understand why the things weren't easier to use.
I think it was bleak. A human being having to punch holes in lots of cards and keep these cards all straight, and then take this deck of what might be hundreds and hundreds of cards to a computer, and you go away and you come back the next day and find out that your program executed up until card 433, and then it stopped because you left out a comma. So you take your deck of cards, and you go back and you fix that, and you go back to the computer again, and this time the program got to card 4006, and it stopped because you forgot to punch a O instead of a 0, or some other stupid reason. I think it was bleak. I think it was dehumanizing.
A group of Stanford students filmed their experience, perhaps a little exaggerated. If programmers were driven to suicide by computers, what chance was there for ordinary people ever to use them? Yet within a few decades, the image of the computer would change. Like the book, it would get smaller, cheaper, and become so easy to use that millions would become literate in the new medium.
We're going to show you a man actually talking to a computer in a way far different than it's ever been possible to do before.
Surely not with his voice.
No, he's going to be talking graphically. He's going to be drawing, and the computer is going to understand his drawings. And the man will be using a language, a graphical language that we call Sketchpad, that started with Ivan Sutherland some years ago when he was busy working on his doctoral degree.
In an era when almost everybody thought that computers were only for crunching numbers, a young graduate student, Ivan Sutherland, had used clever software to make the computer manipulate engineering drawings. With Sketchpad, Sutherland had created the field of computer graphics, and almost 30 years ago demonstrated the power of a whole new way of talking to the computer, interactive computing. But would anybody listen?
We were off to a fabulous start in 1960 with Ivan Sutherland's Sketchpad, one of the most extraordinary programs ever written. And the amazing thing to me is that this did not start a vast movement. In fact, it just stood there as an example that people would gaze at. They'd look at the movie and say, yeah, gee, well, that's very inspirational. And then they'd go back and do exactly what they were doing, which had nothing to do with interactive computing, because there wasn't any interactive computing.
If every one of us does our job well, it'll all go very interesting, I think.
A few years later, another visionary, Doug Engelbart, appealed to his colleagues to change the way they thought about computers. In a spectacular demonstration, he showed off a series of brilliant innovations, including a pointing device called a mouse.
I don't know why we call it a mouse. Sometimes I apologize. It started that way, and we never did change it.
Doug Engelbart is the single most important person in the history of computing, and it's shocking how few people have actually heard of him. It would be as if we all use electricity and light bulbs, but nobody had heard of Thomas Edison.
25 years later, Doug Engelbart walks unrecognized on the Stanford campus. His bold gamble didn't come off.
We just thought, boy, then within a year or two there'll be all sorts of people joining this pursuit, and it become more of an acceptable activity. And, you know, it seemed to, and what I hear from various places is that it stimulated and motivated some people, but it didn't seem to connect as to something that was a viable strand of pursuit for people to pick up, and it just didn't.
Commercial computer makers were slow to see that computers might become a tool for ordinary people, and just didn't get the point of what Engelbart and Sutherland were saying.
Because the establishment never gets it. That's how it is with paradigm shift. The establishment does not see where the next wave is coming from. And even if they hire somebody to tell them where the next wave is coming from, they never believe them, which is exactly what happened with Xerox and Xerox PARC.
One of the implications of Engelbart's demonstration was paperless communication. And that did not go unnoticed in one quarter.
Thank you, Debbie. That was fast. Which is the original?
I forget.
You've just seen the Xerox 9...
The Xerox Corporation owed its prosperity to paper copying. If one day paper was to be outdated, then they wanted to be part of the new electronic world. So, in a visionary act, they set up a research center at Palo Alto.
The reason that most of us went to work there was that we felt that this would be an opportunity to bring computing to everyone. Remember, a computer at that time was thought of as something that was very forbidding, difficult, highly technological. You had to be a real expert and a doctorate to understand. You know, that was kind of the public image. And we somehow had to humanize computers and make them a common object that anyone could use.
In the years ahead, this unconventional group of young scientists sought a different way of interacting with a computer. But they knew they had far too much technical knowledge to understand the problems of the ordinary user.
Technical people live in this tiny little world, actually. We like to think it's a big world, but it's actually a tiny little world. And it's full of phrases that we learned when we were taking math classes. And it's hermetic. And it's full of people who like to learn complicated things. They delight in it. And so what you need to have is some way of constantly shocking yourself into realizing that the users are not like us. And children do it really well, because they don't care about the same kinds of things that adults do. And they can always go out and play ball. They haven't learned to feel guilty about not working yet. It forced us to start thinking about how human mentalities might work.